In aldol reaction, aldehydes are the reactant and in presence of a strong base, they gives addition product named beta hydroxyaldehyde. In the product, aldehyde and hydroxy or alcohol group, they both present together. But how does the aldol name comes from? It comes from the aldehyde and alcohol. From aldehyde, ALD is taken and from alcohol, all is taken. And on combining both of them, we will get aldol. In every addition reaction, there is an electrophile and a nucleophile. So what are the nucleophile and electrophile in aldol reaction? As we just have learned, in aldol reaction, aldehyde or ketones are the only reactant. Carbonyl group of one of the aldehyde act as an electrophile, while the enolate ion formed by one of the aldehyde act as a nucleophile. So let's see how carbonyl carbons serve as an electrophile. This is the carbonyl group. In carbonyl group, electronegative oxygen is bonded to carbon. And that's why there is polarization in the molecule. And as a result of it, partly positive charge develop over carbon and partly negative charge develop over oxygen. This partly positive carbon act as an electrophile. Now come to the formation of nucleophile, that is enolate ion. So let's take the example of aldehyde. This is the carbonyl carbon. One valency of the carbonyl carbon here is satisfied with hydrogen and other valency is satisfied with the methyl group. Carbon that is bonded with carbonyl carbon is alpha carbon. This alpha carbon has formed 4 sigma bond. So the hybridization will be sp3. And this carbonyl carbon has formed 3 sigma bonds. So the hybridization will be sp2. And there is electronegativity difference between sp2 and sp3 hybridized carbon. sp2 hybridized carbon is more electronegative as compared to sp3 hybridized carbon. So it will withdraw electron density from sp3 hybridized carbon. And this sp3 hybridized carbon will withdraw electron density from hydrogen. So that's why this hydrogen will become acidic in nature. That means this hydrogen can be released in the form of H+ ion. So in the presence of base will abstract this alpha hydrogen and this alpha hydrogen will leave as H+ ion and transfer its bonding pair of electron to the carbon. And as a result of it, negative charge will develop over alpha carbon. As this aldehyde donates H+ ion, it acts as an acid while the formed anion is known as conjugate base anion. So let's see how stable is the conjugate base anion. More stable the conjugate base anion, stronger will be the acid. In this conjugate base anion, negative charge delocalize between alpha carbon and carbonyl carbon and double bond delocalize over oxygen. As a result of it, enolate ion is formed in which oxygen carries negative charge. This resonating structure is stable because octet of each element is complete and negative charge here is on electronegative oxygen that is more stable. That's why this enolate ion acts as a nucleophile in aldol reaction and it is formed due to the acidic nature of alpha hydrogen. So you might wonder here why this aldehydic hydrogen is not acidic. So let's see why aldehydic hydrogen not acidic. If base abstract this hydrogen from aldehyde, negative charge will develop over the carbonyl carbon. So here aldehyde will act as an acid while the formed anion will be the conjugate base anion. Stable the conjugate base anion, stronger will be the acid. So let's see whether this conjugate base anion is stabilized by any of the effect. When this negative charge delocalizes between carbon and oxygen, as a result of it, triple bond is formed between carbon and oxygen. Now one of the bond is moved over oxygen and as a result of it, negative charge will develop over oxygen and positive charge will develop over carbon. In this resonating structure, octet of carbon is incomplete and oxygen gets more than 8 electrons. So that's why this resonating structure is not stable. So that's how this conjugate base anion is not stabilized by any of the effect. That's why this acid will be the weak acid. And that's why aldehydic hydrogen is not acidic in nature. Now let's revise the electrophile and nucleophile in the aldol reaction. As we just have discussed, when base abstract alpha hydrogen from the aldehyde. It results in the formation of enolate ion. And this enolate ion acts as a nucleophile. Here this double bond will act as a nucleophile in the Aldol reaction. And due to polarization in carbonyl group, another molecule of aldehyde acts as an electrophile. Here this positively charged carbon serves as an electrophile. Now come to the mechanism of Aldol reaction. In the presence of base abstract alpha hydrogen that is bonded to alpha carbon. After the abstraction of alpha hydrogen, enolate ion is formed. This nucleophile reacts with an electrophile that is another molecule of aldehyde. During the attack, negative charge of oxygen delocalizes between carbon and oxygen, and through the double bond, it attacks to the carbonyl carbon of another molecule of aldehyde. And here this double bond moves over carbon. As a result of it, negative charge will develop over oxygen and nucleophile get attached to this carbonyl carbon through alpha carbon. If I number the carbons over here, if I number it 1 and this is 2 and this is third carbon. This is the third carbon and second carbon is bonded to third carbon. So this is the second carbon and it is the first carbon that is bonded to second carbon. Now this anion will abstract hydrogen from the water molecule that is formed in the first step. After the abstraction of H plus ion, OH minus ion will be formed and you will get this molecule. Here OH minus was involved in first step of the reaction and it is regenerated in the last step of the reaction. Hence here OH minus acts as a catalyst. Now name this molecule. Here aldehyde is the primary functional group and OH is the secondary functional group. Carbon next to primary functional group is alpha carbon and carbon next to it is the beta carbon. So the name of this molecule will be beta hydroxy aldehyde. Here we have used prefix for secondary functional group, that is OH. So that's why we have used hydroxy over here. Now when this beta hydroxy aldehyde is further heated, there is alpha beta elimination take place. During the alpha beta elimination, H plus will be eliminated from alpha carbon and OH will be eliminated from beta carbon. Result of it, double bond is formed between alpha and beta carbon and water molecule is formed as a byproduct. This formed molecule is alpha beta unsaturated aldehyde as there is unsaturation between alpha and beta carbon. If ketones are the reactants, what are the nucleophile and electrophile for Aldol reaction? So let's see the mechanism of Aldol reaction when ketones are the reactants. Here this is the ketone because the carbonyl carbon is bonded to two alkyl groups. In the presence of base, it will abstract alpha hydrogen from the alpha carbon and as a result of it, enolate ion will be formed. Now this enolate ion acts as a nucleophile that will react with another molecule of ketone that will act as an electrophile. So negative charge of oxygen delocalizes between carbon and oxygen and through the double bond, it will attack over carbonyl carbon. And now this double bond move over oxygen and as a result of it, negative charge will develop over oxygen. If I number this molecule, this is 1 carbon, carbon 2 and this is carbon 3. So here this is carbon 3. It is bonded to second carbon. Here this is second carbon and this is first carbon. Now this anion will abstract hydrogen from the water molecule. Here OH minus ion that is consumed in the first step is regenerated in the last step. That's why it is act as a catalyst. Now name this molecule. Here ketone is the primary functional group and OH is the secondary functional group. Carbon bonded to primary functional group is the alpha carbon and the carbon next to it is the beta carbon. Here OH group is bonded to beta carbon. So the name of this molecule will be beta hydroxy ketone. When this beta hydroxy ketone is further heated, it will undergo alpha beta elimination. H plus will be removed from alpha carbon and OH minus will be removed from beta carbon and as a result of it, double bond will be formed between alpha and beta carbon. So there is unsaturation between alpha and beta carbon. So this molecule will be named as alpha beta unsaturated ketone. If reactants are ketone and aldehyde, which one will act as a nucleophile and which will act as an electrophile? To get that answer, you need to compare the electrophilicity of carbonyl carbon of aldehyde and ketone. First one is the aldehyde and second one is the ketone. They both have carbonyl carbon, and due to the polarity in carbonyl group, carbonyl carbon is partly positive. In aldehyde, there is one alkyl group. It donates electron density through plus I effect. That's how it reduces some amount of positive charge over carbonyl carbon. In case of ketone, there are two alkyl groups that donate electron density through plus I effect. So in case of ketone, positive charge has been neutralized by plus I effect of two alkyl groups. That's why in aldehyde, carbonyl carbon has more positive charge as compared to that of in ketone. So that's why aldehyde will act as an electrophile and ketone will act as a nucleophile. Because aldehydes are more reactive towards nucleophilic addition reaction. Now come to the mechanism of Cross Aldol reaction. Base will abstract alpha hydrogen from the ketone, and as a result of it, enolate ion will be formed. This enolate ion acts as a nucleophile. It will attack over aldehyde that will serve as an electrophile. So negative charge of oxygen move between carbon and oxygen, and through double bond of carbon and carbon, it will attack over carbonyl carbon. Now number these carbons. So I will number it 1, this is 2, and this is 3. So this is the third carbon, and second carbon will bond it to third carbon. So this is second carbon and this is first carbon. Now this anion will abstract hydrogen from the water molecule and OH minus will regenerate. OH minus that is consumed in the first step is regenerated at the last step. That's why OH minus acts as a catalyst in this reaction. Here ketone is the primary functional group and the carbon to which it is bonded is the alpha carbon and carbon next to it is the beta carbon to which secondary functional group that is OH is bonded. So the name of this molecule will be beta hydroxy ketone. And when this beta hydroxy ketone is further heated, it undergo alpha beta elimination. H plus will be removed from alpha carbon and OH minus will be removed from the beta carbon. As a result of it, double bond will be formed between alpha and beta carbon. And this molecule will be named as alpha beta unsaturated ketone. If reactants are two different aldehydes, then which one will act as a nucleophile and which one react as an electrophile? To get the answer of this question, you have to compare the electrophilicity of both the aldehydes. Here I have taken two different aldehydes. One is ethanol and other one is propanol. In ethanol, methyl group will donate electron density through plus I effect. In propanol, this ethyl group will donate electron density through plus I effect. So when you compare the plus I effect of ethyl and methyl, ethyl will have more plus I effect than methyl. So that's why the aldehyde that has a smaller alkyl group will be more reactive towards nucleophilic addition reaction. So this one will act as an electrophile and the another molecule that has bigger alkyl group will serve as a nucleophile. Let's try to find out what would be the product if they both react together. Here OH minus ion will abstract hydrogen from the propanol. Here this is the alpha carbon. So it will abstract alpha hydrogen from the alpha carbon. As a result of it, enolate ion will be formed. Now this enolate ion will attack over methanol. Negative charge will delocalize between carbon and oxygen and through double bond it will attack over the carbonyl carbon and now this double bond will move over oxygen. Now number the carbon. This is carbon 1, 2 and 3. This is carbon 4 and this is carbon 5. So this is fourth carbon that is bonded to fifth carbon and now second carbon form bond with the fourth carbon. So here this is second carbon and the second carbon at the same time it is bonded to carbon 1 and bonded to carbon 3. Now this anion will abstract hydrogen from the water molecule and OH minus ion will be formed. And this molecule will be formed. Here aldehyde is the primary functional group and the carbon next to it will be alpha carbon and the carbon next to alpha is the beta carbon. Here hydroxy group is bonded to beta carbon. So this is beta hydroxy aldehyde will be formed. So if you write the IUPAC name of this molecule, first of all select the longest carbon chain that includes your primary functional group. So here carbon 1, 2, 3 and 4 carbon long chain. So for 4, parent name will be but. Now identify the substituent. So here methyl substituent is there, that is bonded to second carbon, and secondary functional group OH is there. So here we have to use the prefix for OH, that is hydroxy. So the name of this molecule will be 2-methyl 3-hydroxy butanol. So when we further heat this molecule, it will undergo alpha-beta elimination. H plus will be removed from alpha carbon and OH minus will be removed from the beta carbon. And as a result of it, double bond will be formed between alpha and beta carbon, and alpha-beta unsaturated aldehyde will be formed. In the next video, we are going to discuss Cannizzaro reaction.